Hello. So here we have a server and a client, and the server is remotely connected to my PC, and now they are going to communicate over Bluetooth. So first, let me run the program and show you they are actually connected over Bluetooth. So okay, so you can see that my client is connected to the server, and the way it works is that the server is sending telemetries of the car to the client. You can see it in my command window, that the server receiving a message and then sending a message to the client. The message that the client receives is in the command window here. It contains the speed of the car, the distance it reached, the CPU temperature, and the battery level. And the client can send a command of the car direction. It can tell the car to move forward, backward, to the right, or to the left. It can also tell the car to pause or to exit the program. Now I will show you how it works. The client controls the car movement by moving the mouse. So now I'm going to tell the car to move forward, and I'll tell it to move to the right and to the left. Now I want the car to move backward and pause. And this is it. Thank you. This function responsible for the server side. This is the MAC address of the Pi. And here the server is opening a socket using the MAC address and the port number we define, and listen and wait for a client to reach him. The client shall use the MAC address and the port number, and those are initial values. I will explain in more details shortly, of a timestamp and distance the car reached. Once a connection is established, the client can send a message to the car, to the Pi, and the message will contain the car direction. By default, it is hold, meaning the car doesn't move, but it can also be either forward, backward, turn right, or turn left with a fixed speed of the car. Here I'm getting an updated timestamp so that I can calculate the distance and sum it for as long as the communication is still holding. And on this section, the server is preparing the packet to send to the client with the telemetries of the car. You may notice I chose for the direction to send only one character. For example, I will only send F instead of the whole word forward to save space. And in addition, I made the message to be of a fixed structure and size to make it more convenient. So this is the message the client will receive. And once the client abandoning the communication, the server may close the socket. And this is it. Once a client establishing the communication and with the server, it may send a message to the server, and this message will contain the direction the car should move, a command for the car to move either forward, backward, right, left, or pause, hold. The way I chose to implement it is using the screen size and the mouse position regarding the screen size. Meaning, if the mouse will be in the upper side of the screen, then the car should move forward. Otherwise, it can move backward, turn right, turn left, or pause if it's in the middle of the screen. So here, the method onMove, I'm calculating the position and determining what is the command that should be sent to the car regarding this position of the mouse. And I also choose to add this method on click, which basically closes the connection once the right click of the mouse is clicked. The right button, sorry. So the client is joining the server using the MAC address and port number. And here the client receives the message containing the telemetries the server sent him. Okay, so here we have a similar setup. We have our server and the client, and they are going to communicate over Wi-Fi. The client now will use a JavaScript front-end application, and I will run it and explain simultaneously. So here it is. This is the application. The server will send telemetries of the car, and the client controls the car direction and also the car speed by incremental velocity. Let's see how it works. So I can tell the car to move even faster or slower, and maybe pause. Now I want the car to go to the other direction, move to the side, do it faster, and slower, then go to the other direction. I can try to move really fast if I want to. And now I'm going to decrease the velocity and tell the car to pause. And this is it. For establishing a Wi-Fi communication, the client should use the IP address of the car, of the Pi, and a different port number. Also here, the client will send a message that contains a command of the car direction, the direction the car should move. But I also chose here to send the speed of the car on each message. So the client is not only telling the car to move forward, but also determine the speed to do this step. And again, the server is preparing the telemetries to send the packet for the client. It's pretty resembling what you've seen in the previous section. And this is it, the Wi-Fi server function. For this part, I mainly used the code given by the course staff right here. And I will mention the things I updated in the file index.js. So this is the function client, and it is responsible for two things. It sends the server the message from the client, and it also receives the telemetries from the server. It's happening here. Another thing I added is this function, parse message. I split the command either to forward, backward direction or turns. In the case of a straight line, if the user chooses to move in the same direction, the velocity will increase, and for the opposite direction, the velocity will decrease. And this is also true for the left-right turns. The calculated speed is concatenated to the end of the command. So this is calculating here, and those are the options. So the client can tell the server move forward, backward, left, right, or pause. The last thing I want to mention is here in the index.html file, I've added another field of a battery level, and this is it.